So far I've been through all the things stating the for loop, the flashing, the while loop, things like that. Alright, the purpose of that is actually to introduce you with an exam question or related to the exam question or the exam level type of question, so to speak. Alright, because in this question it's gonna relate to all the stuff, alright, that we have discussed earlier, and that I would like to do the flowchart with regards to this thing. Okay, my explanation may not be very good, but so yeah. One thing you need to take note of is something that is pretty relevant, is that you need to know three things. Alright, you know that the English itself, you need to really know how to decipher. Second one is you need to settle on with how the hertz is being calculated. Alright, because it states that flashing twice, flashing 5 times, things like that, which is very tough to actually compute. So there is a cheat code for you to take note of the hertz, and then the mind map of how do you set up the mind map of what is the a bit of a cheat code to actually write down the mind map in a way that is easier for you to write in a way. So therefore this video shall build on these things. So without further ado, we just start off with this question. So as I say, the English itself is very important because the first sentence, pressing the button momentarily turns the device on. Alright, the word momentary already, like, really seriously don't know what the hell already, right? The meaning itself is just that when you press the button, alright, the device is on. That's it. Alright, so when you press the button, the device is on. Finish. Alright, and it's indicated, so after you press the device, the LED flash twice with 1 Hz. Alright, later on we'll talk about that. Alright, and then after the second step is that it says that hold down the button for 5 seconds or more, you'll turn the device off. Okay, and once how do you define it's off is that when it is off, alright, the LED will actually flash 5 times at 2 Hz. Okay, somewhat like it's the device that is off, so to speak lah. Alright, later on you'll get the meaning also. Alright, next, while the button is held down, this is indicated by the LED continuously flashing rapidly at 4 Hz. And this is coming from nowhere. Alright, when the button is held down, so when you press the button, alright, LED is flashing. Okay, then where it goes. Alright, so this thing actually is the middle part of your mind map. So therefore, you have somewhat see that the English itself has come into play because you need to decipher the language of how they actually write it. Alright, so now let's talk about the mind map. Alright, how do you define what is the top part, the start, the body, and the end? Okay, so one method is that you just take note of the word on, device on. If there is a sentence that tells you that there's a device on, this means that the whole sentence is talking about the start. Alright, start is defined by this particular circle rectangular, or curl edge rectangular, because there's a curl edge over here. Okay, so straight away you know that there is a start. Okay, and this start tells you that when you press the button, it's alright, the LED will flash. Okay, so in order to start, alright, I'll press the button, so I'll just write it down, and there's a point where you need to take note. Alright, when you press the button, you can also don't press the button. Alright, so you're gonna denote as a question. The question, the flowchart, the symbol that tells that, how do I say, the symbol that represents a question is a triangular, a diamond shaped thing. Alright, so if you didn't press your button, it will tell you that it's no, so you'll go back to this thing. If it's yes, then you continue. Okay, so this is something that you really need to know when you set up your stuff. When you're talking about a button, please take note of the no or the yes, this kind of stuff. Alright, next, let's kind of ignore the twice at 1 Hz first. Okay, let's define where is the device off. The device is on, definitely it will off 1 time. I mean, when the device is on, definitely there's a point where it's off. So as you can see, this is off at the second point. Alright, so most likely you know that this part over here is a device off. So over here, device off, you just write it as end. Alright, because the device is off, and it's denoted by this shape also. Okay, So you know that you have somewhat built up the start and the end of the flowchart already. Okay, so now what can we do about this? And you may wonder, what if there's no device on or off, or maybe there's only one device on but there's no device off. If there's no device off, normally they will say like first something something something, second something something something, third something something something. So you can follow the first, second, third to actually plot your flowchart, things like that. Hopefully they will do that. If otherwise, then you are KO. Alright. So therefore, when you see the device off, whatever thing that tells in this particular section where the device is off, alright, is a step before the device is off. Alright, so there is one step before the device is off. So one step before this device is off is that particular step. I'll just write it as something first. Okay, so at least you know that the particular step is within this second sentence. Okay, so now we're gonna fill in the body. So the body is this thing. Okay, so I'll just write it as 3. Alright, sentence 3. So most likely you'll see that the body is all over here already. Okay, so now how do we evaluate the body? The body part is actually one of the most tedious part to solve. Okay, and the most one of the tedious part, alright, one of the tedious part is your hertz. Okay, how do you set up the hertz? Alright, normally when you tackle this type of question, the first thing first is what? Alright, straight away compute your stuff. Alright, when you're talking about flashing LED okay, most likely flashing of the LED, then you can straight away use this equation. Alright, T over 2 is equals to 1 over 2 hertz. Alright, so you just need to find 1 over 2 hertz and that's it. Alright, 1 over 2 times hertz, so to speak. Alright, yeah, so it's 1 over 2 times hertz. Why do we divide the period by 2? For example, if let's say we have a period of 1 second, alright, from 0 to 1 second. Okay, so a period, as you know, is something like this, correct? Or we can also rewrite it as something like this. Sorry, yeah, something like this. Okay, so this is one period, right? Same thing lah. Okay, but I just draw it in a way that tells you that this is high and then this is low, something like that. So your flashing LED is actually one period. Okay, over here it's high and then over here it is low. Alright, so in order to flash one time, you need one period. Okay, as I repeat again, in order to flash one time, alright, so when you flash one time high and then you're low, this whole thing is one flash, one period. Alright, so within this particular one flashing or one period, you'll have this half point where half of it is high, half of it is low. Alright, so therefore we are taking this particular half frequency. So this is why I'm taking T over 2. The period divided by 2. Because if you were to remember back in our coding for the flashing, okay, yeah. So over here, you said you still remember, I think, is it last video? Yeah, anyway, if it's not last video, but anyway, this thing sets the function as flash. So instead of setting it as initialize the function, you set as void so that it can be read by the thing, by your Arduino. If you watch my previous video, you'll know that why do we use void. Alright, so void flash your particular function, your input duration, alright, and the time the number of time you want to flash it. Okay, so how it works is that over here it writes high for some delay and then it low for some delay. Okay, so it corresponds to our just now our diagram, right? So over here it is high for some period of time and over here it is low, correct? So this thing is half of a period, which is 0.5. Alright, so half of it, so if you want to flash one time, this is flashing one time, so you flash and then off and then flash again and then off. So this thing is flash one time, flash two times, so to speak. Okay, I hope that this is pretty clear for you. So therefore, this is the proof that you need to actually divide your period by 2. Okay, and you no need to do other stuff already. Okay, so this duration, that is 0.5 for this case, alright, is being placed over here because for when you on, so when you flash your stuff, okay, your LED will first light up and lag for 0.5 second, and then you off, and then off for 0.5 second, which is this code over here, and then after that, if it's flashing again, it will light up again and then carry on flashing other stuff. Okay, so therefore this is something that you may need to understand. Alright, therefore the cheat code takeaway for the hertz itself is only this particular thing. Alright, if you want to find if you remember just now, what I write is the flash, the number of seconds you want to lead, and the number of times you want to flash. Alright, so over here the calculation is straight away this one. You just put it in and that's it. Okay, straightforward, right? 1/2 times your hertz. Alright, so let's just try out the first one. Okay, so we have LED flash twice at 1 hertz. Okay, so therefore I'll have equals to 1/2 times 1, which is equals to 0.5. Alright, because it's in terms of, because actually I should write as 1000 seconds, because this is 1 second, this is 1000 millisecond. 1000 millisecond is equals to 1 second. Okay, so instead of writing that, I'll just write as 500 millisecond. Alright, so over here this tells us what? This tells us for one period, alright, you have what am I doing? This is 500 millisecond, this is 500 millisecond off. Alright, so this is only one flash. Okay, so one flash, it's 500 millisecond. While how many times do you flash? It tells you that flash 2 times. So you just simply put it over here as times 2. That's it. Okay, simple as that. So therefore, if you were to take a look, alright, so when your device is turned on, alright, your LED will flash twice at 1 hertz. So we can just simply write it down already, right? So I'll just simply move this thing. Hold on a while. So therefore, I'll just write as flash, then bracket 500 millisecond, flash 2 times. Alright, so one time flash. Alright, flash 1 time is 500 millisecond. And then it's flash for 1 time. It flash. What do I say? For 1 time, the half of the period is 500 millisecond. Okay, so over here you flash 2 times. I think you get what I mean. Okay, so this information, it tells you that for one flash, how many millisecond do you need okay, how many millisecond do you need for half of the period. Alright, so if you just take a look, is this thing. So it's just asking you what is this thing or this thing. Alright, this thing is your one of the period. Alright, 0 to t whatever period that you want. Okay, so it's just asking half of your period, and that's it. Alright, because this half of period will denote, because half of it is on, half of it is off. Alright, so this thing over here is one flash. Alright, so this information is being put over here. So one flash you require 500 milliseconds, and because we need 2 flash, so just put 2 and that's it. Okay, the counter will count for you because there is a for loop within it. I will not go and explain what is the for loop used. You just watch back the previous video. Alright, so therefore this is it for the flash part. Okay, so we have cleared away the step 1. Alright, we have cleared away this part over here. So now we know that there is a body. The body is actually the step 3, right? Because the step 2 is actually the device off, the last step. Okay, so the body over here is that it continuously flash rapidly at 4 hertz, and then flash how many times, I don't know. Alright, that's the point where we seriously don't know what the hell is going on already. Alright, and therefore no scared. Alright, we have this superpower Gaylord so-called equation. So what we can do is also do the same thing. Alright, so 1/2 times your hertz is what? In this case now we have 4 hertz. Alright, shown over, where am I? Yeah, this one. Okay, therefore 1/2 times 4, which is your hertz, this equation. Alright, you will have 1/8, which is equals to I should have write as 1000 millisecond. Okay, this, so next time on you should know that is 1000 divided by 2 times hertz, your millisecond, right, in terms of millisecond. Okay, so over here you have 125 millisecond. Okay, but because we don't know how many times it flashed, because it's just saying that it flashed rapidly, we don't know how many times, but we know that it caps at 5 seconds. Okay, think about it. So when the button is held down, is indicated by the LED flashing for 4 Hz, alright, until holding the button down for 5 seconds or more will turn the device off. So when you hold it for 5 seconds or more, this particular sentence will comes in. Okay, so you know that this particular limit is until when you hold it for 5 seconds. Alright, you get what I mean? But therefore, how do I write in terms of this form? Okay, flash. Alright, flash what? Now we only have one information, we only have 1 to 5 milliseconds. How can I do that? Alright, so therefore we need a counter, which is therefore we talk about the for loop in the previous video already. Okay, so therefore I'll just simply bring this down. I think there'll be a pretty big chunk of stuff. Okay, so now be careful of the words, alright, while the button is held down. So you still need to press the button again. Okay, so these are the little stuff that you need to take note. At first you press the button momentarily. So I think he's just trying to tell you that momentary is just when you press and then you let go, and that's it. Alright, while held down is you press and hold it for a long time. So he's trying to differentiate. That's why he used the English in that particular manner. Alright, wait, so therefore this thing over here you press already, you press fast chop, plum, the device is on. Now I want to hold it down, so I need to pre-press my button again. Okay, so I've pressed my button. Alright, and then this is the question. Normally when you press the button, you need to ask yourself, did I press or did I not press? Alright, so if I never press, it will go on like this. Alright, if otherwise, alright, then I carry on. So I carry on. The next step is to input the flash. Okay, I know that I have to input the flash. Just cycle yourself. It's 125 milliseconds, which I've proved to you just now over this calculation. Okay, so since they didn't indicate how many times it flashed, well, just write but we know that for one time flash is 125 milliseconds, so just write as one flash will do. Okay, so we only flash it by one time. Alright, and then we draw the shape of your function, your flowchart, so to speak, as this rectangular. Okay, because this is something that you will need to do. Okay, so now you keep on flashing for one time. Alright, but you cannot straight away go into end already, right? Because there's a limit. Alright, if you hold down for 5 seconds or more, you will turn the device off. When you hold down for 5 seconds or more, this thing will activate. Okay, so your limit is kept at 5 seconds. Okay, currently our period is 1 to 5 milliseconds. Okay, so how many times do I need to hold until it reaches 5 seconds? Therefore, you may be tempted to actually take the 5 seconds to divide by 125, or the 5000 milliseconds divided by 125. Don't do that, please. Okay, because if you were to do in terms of this thing, so if you are dealing with trying to find the number of times you press because now over here this is t over 2. Alright, if you still remember, half of your button is pressed, half the button is not pressed. Alright, so this is one period, right? One period to whatever period you want. Okay, so therefore find how many times you press, alright, such that it reaches 5 seconds. Alright, you're gonna talk about finding your time over your period. If that doesn't sound very familiar, this is actually equals to your frequency. Okay, so by standard is actually overall is 1 over t, but you can also say that for time divided by period, you can also get your frequency. Okay, so this is another cheat code that I think is fairly useful after I think about it. Alright, so I think I'll just put it over here. Okay, so there is 2 cheat codes for the frequency that you need to calculate. Alright, the first one is this one, the time, whatever time that you want to reach, divided by the period that you want, that you have. Alright, and the second equation is this one. Okay, so you need to know when do you use these two. Okay, so I think that this is fairly useful. What if happen that you have your limit is 5000 seconds and our period is actually 125 times 2, because the period is t over, now this thing over here is t over 2. So the period for this case is actually 250 millisecond. Alright, because 125 is equals to t over 2, so 250 is equals to your period. Okay, so if you find it mathematically proven. Alright, so therefore the time 5000 millisecond divided by your period will give you equals to 20. Okay, so the 20 times you press, alright, so you press this 20 times, okay, you'll reach 5 seconds and you'll turn the device off. So in this case, as you can see that we can somewhat have a counter. Okay, so this counter over here, you can just write the first thing as, maybe I should write in a different color, maybe in green. So counter is equals to counter plus 1, or increase by 1. Okay, it tells you that, so when you press this thing, alright, you'll increase by 1. Okay, when it increase by 1, then it will feedback, it will come to here where you ask, so there will be a question to be asked, whether is your counter smaller than 20. So when it reaches 20, alright, when it reaches 20, alright, you actually loop out. Okay, so you actually go into the second one, right, which is this one. Okay, where am I? Yeah, which is this sentence. So when you reach 5 seconds, this sentence is activated. Okay, if you still remember. So therefore over here, if counter is less than 20, okay, then you will continue to go back to here to carry on with the flashing. Okay, so this is no. Alright, so if counter is not less than, wait yeah, I think this is yes leh. Alright, in the book actually they keep on saying no, but I think it's yes, because is your count, this question asks, is your counter less than 20? Definitely yes ma. So if yes, then you continue to loop and loop and loop until when you reach 20. Is your counter less than 20? No, then you carry on. Okay, so this is one phrase you want to remind yourself. Okay, so please take note of this thing. Okay, so and also take note that in the lecture they actually write this as no, they write it as yes. Okay, so this is something that you need to take note of. Alright, and therefore if your counter, alright, is not less than 20, alright, which is no, then you come to the next step, which is this one. Alright, this particular sentence already. Okay, so this means that you're preparing to turn off your device. Okay, so in order to show that you're turning off the device, okay, you're gonna flash 5 times at 2 Hz. Alright, when I talk about flash 5 times at 2 Hz, then you're gonna talk about using this equation. Okay, when you're talking about in terms of Hertz, alright, then you're gonna use this type of equations. Alright, so 1000 divided by 2 times how many? He says 2 Hz, right? So therefore I would have 2 times 2 is equals to 1000 divided by 4, which is 250 milliseconds. Okay, so for one period, alright, this is half a period, sorry, but as for one period, this is period 0 to some period you are, alright, half of the period will be on, half of the period will be off. I keep on repeating myself because I just want to tell you. So over here this is 250 ms, millisecond. Okay, so therefore what I can do now is also to write it as this thing. Alright, so my particular stuff over here, I can finally fill it out. I'll just write it as a orange color, flash 250 millisecond, which is what we have calculated. For 250 millisecond for each of the period, for each period, for each flash, alright, so to speak lah, okay, and then you flash for how many times. It tells us that how many times do we need to flash. So they tell us to flash 5 times. Okay, so I'll just write as 5 times. Okay, and therefore I'll just put it out over here. Okay, so this is it for the end, right? Okay, so here's the summation of what you can take home is that firstly you need to know how the English is being plotted out. You need to firstly understand, if otherwise then 笑了. Okay, but anyway, I'll just suggest that you read it up more and more, so that so for a question you just read a few times such that you fully understand what the codes want. Once after that, Alright, most likely I think it'll talk about buttons lah, because buttons is always being used. So in terms of buttons, you'll talk about the hertz and things like that. So the hertz one, straight away, if they tell you to flash twice, flash 5 times, or they didn't tell you, when you see hertz, alright, straight away you know that this is the equation to be used. Okay? And there's a point where they design it such that you hold down a button for 5 seconds, alright, how many times do you need to press the button, or how long do you need to press the button in order to reach the 5 seconds. So in such a case to happen, you need to talk about time, your particular time that you want to reach, divided by the period. Alright, and please take note that over here this thing over here, you're calculating half period only. So if you want to find the period, you need to times 2. Okay, so therefore you can find the frequency of your counter. Okay, if you just take a look, this is the counter that we have just say over here. Okay, and then after that, the most importantly, the mind map lah. Okay, the mind map issue you need to know is that take note of the device on, device off, so that you know when is the end, when is the on of the device, where is the end of the device. Or take note of those words like first you need to do what, second you need to do what, things like that. Okay, and then always denote your button. Alright, when you do button, straight away you know that you need to write yes or no. Okay, it's something that you need to know. So when everything about button, first thing comes first is the diamond shape, yes or no. Okay, press the button, yes or no. Alright, next is the counter. Normally counter have 2 block diagrams if you take a look. Alright, your counter will have counter is equals to counter plus 1. Alright, after that is when counter reach a certain frequency that you want, how many times you press. Alright, then if it's yes or if it's no, then something else. Okay, so you need to know that there is 2 parts for the counter, so which is this one part and 2 parts. Okay, and the last one is the flash, the equation that we keep on using, flash 500 millisecond to this thing over here is t over 2 your half period, which is calculated from here. Okay, once you calculate it from here, and then next you sub in your number of times you're going to flash it. Okay, so normally you need to indicate to the reader, alright, in test, that what is actually this thing and what is actually this thing, how many times you flash and things like that, so that when they read your mind map or your flowchart, at least they know what is the meaning and they will give you marks. Okay, so I think is it for setting up the flowchart. So in the next video I'll just show you the program, alright, and you'll get to see how it is in real life. See you there.